Okay, so let's go ahead and wrap up the next two. So again, we're given a 70.5 degree angle. So one of the angles I don't know is this guy here. So again, how about I just call that beta, right? We don't know the, we're given the opposite, and it's the hypotenuse and the adjacent that we don't know. So those are the three things that we need to find. Again, I think beta is probably the easiest thing. Because of the 90 degree angle, we know that beta plus 70.5 degrees should be equal to 90. They're complements. So subtracting 70.5, I believe we get that beta is 19.5 degrees. All right, so there we have that. All right, so beta is 19.5. So to find, let's go ahead and work with our adjacent. What's given, right, is adjacent and the opposite. Well, that's tangent. So we know that the tangent of, or excuse me, yeah, so 70.5, right, that's the opposite. So the tangent of 70.5 degrees is the opposite, 15, divided by the adjacent with regards to that. So I'm using my definition there. So now we got to solve for the adjacent. So again, perhaps we divide both sides by that adjacent, or excuse me, multiply. That cancels out here, and this will leave us with the adjacent times the tangent of 70.5 degrees equals 15. And of course, to get this adjacent by itself, if I divide both sides by that tangent value, whatever it is, now remember this is an output value, right? This is a number, so I'm going to treat it as a number. And so I'll divide that out, and we basically get our exact answer for the adjacent side. Okay, so again, that is exact. All right, so our adjacent side is 15 divided by the tangent of 70.5. Of course, if I go to a calculator, right, so when I put this on my calculator, I'm looking for, let me turn it back on again, right, this time it's 15, and we're going to divide it by the tangent of 70.5. Right, and when I do that, that returns, it looks like 4 decimals was 3118, so 5.31 and 18 if we round off. So again, that is the estimated value using my calculator, right? So make sure you can do both exact and in the calculator version. Okay. Of course, now we have the adjacent. We've solved for beta, so what's left is hypotenuse. Well, for the 70.5 degree angle, right, the side that's given is opposite and the hypotenuse. So what relationship puts opposite and hypotenuse together? Well, that'd definitely be my sine, right? So the sine of 70.5, right, is the opposite 15 times my hypotenuse. And so if I multiply both sides by the hypotenuse, it'll cancel out, and so we're basically left with the hypotenuse times the sine of 70.5 is equal to 15. And then again, solving for the hypotenuse, I'll divide both sides by that sine of 70.5, and what we get is our hypotenuse value, right? It's 15 over the sine of 70.5. And again, that is our exact value. To get an estimate, all right, we'll just go to our calculator again, and we're looking at 15 divided by the sine of 70.5, right? And that looks like it's 15.9127. So there's your estimated value of the hypotenuse. So we have solved that right triangle. I have a value for the hypotenuse, I now have a value for the adjacent, and I now have a value for the beta that was missing. So everything that's missing has been solved for. We've solved that, and we've done. All right, so make sure you're showing me your algebra, showing me your work. It'd be nice to show me how you entered this in your calculator, just in case you make a mistake and I can follow what you did, right? So that's what I entered in the calculator to get that. And this one was 15 divided by the sine of 70.5, because you just never know. Sometimes you make a mistake And I'd like to try to give you partial credit, so at least show me what you inputted in your calculator, right, to get that answer. So last but not least, we have this guy here. Again, let's call that beta. That's the easy one to find because we're talking about a 90-degree angle. Beta plus 14 degrees must equal to 90. So subtracting 14 from both sides, right, beta, I believe, will end up being 76. Right, so beta is 76 degrees, so we've got beta. All right. So what about the opposite? Well, for the angle that's given, 14, I've got opposite and adjacent, right? That's my adjacent side. So that's tangent. So the tangent of 14 degrees is the opposite over the adjacent, which is 7. So solving for the opposite, I'll multiply both sides by 7. And we basically get our answer. Our opposite is 7 times the tangent of 14 degrees. Right, that's a 7 right there. So again, this is an exact answer. All right, and in terms of getting its estimate, we just essentially just type that in. So let me do it here. Let me find a spot for it. So we got 7. This time we're multiplying it to the tangent of 14 degrees. Press enter. And it looks like 1 and 7453. So 1.7453, and that would be our estimated answer for the adjacent. So far so good. What's missing is hypotenuse. Again, for the angle that's given, I've got the adjacent and the hypotenuse. So what relates the adjacent to the hypotenuse? That's cosine. Right? So cosine of 14 is my adjacent over my hypotenuse. My adjacent is 7. My hypotenuse is what we're trying to find. So we basically have to solve for that. So clearing fractions, I'll multiply both sides by the hypotenuse. And that basically gives us the hypotenuse times the cosine of 14 degrees, right, is equal to 7. And if we now take both sides and divide it by 14, right, we end up that our hypotenuse is equal to 7 cosine of 14 degrees. And again, that's your exact answer. In the calculator, I type it like this and get an estimate of, right, so we've got 7 divided by the cosine of 14. Right, I got my division bar. And it looks like we get a value of 7.2143 as our estimated value. And so now, right, we found the hypotenuse. So there's your introduction to solving for a right triangle. Again, you take what's given and you basically find the other pieces of data that are not given. We're taking advantage of the idea of complements, and we're using our definitions. Sine again, cosine, and tangent really are the big three. The relationship, again, as a reminder, sine of any angle, right, is the opposite over the hypotenuse. I should have said this at the beginning. The cosine of theta is the adjacent over the hypotenuse, and tangent of any angle is the opposite over the adjacent. So we're using our right triangle terminology definition to basically help us solve right triangles. So there's your first round of examples. The next one we'll do are a little bit more wordy, but pretty much the same thing. But we'll see that in another video. See you guys then.